The Lockheed State Route 71 Blackbird is a long-range, high-altitude, The Lockheed State Route 71 Blackbird is a long-range, high-altitude, Mach 3 plus strategic reconnaissance aircraft developed and manufactured by the American aerospace company Lockheed Corporation. It was operated by the United States Air Force, USAF, and NASA. The State Route 71 was developed as a black project from the Lockheed A-12 reconnaissance aircraft during the 1960s by Lockheed's Skunk Works division. American aerospace engineer Clarence Kelly Johnson was responsible for many of the aircraft's innovative concepts. The shape of the State Route 71 was based on that of the A-12, which was one of the first aircraft to be designed with a reduced radar cross-section. Initially, a bomber variant of the A-12 was requested by Curtis LeMay, before the program was focused solely on reconnaissance. Mission equipment for the reconnaissance role included signals intelligence sensors, side-looking airborne radar, and a camera. The State Route 71 was both longer and heavier than the A-12, allowing it to hold more fuel as well as a two-seat cockpit. The State Route 71 entered service in January 1966. During aerial reconnaissance missions, the State Route 71 operated at high speeds and altitudes, Mach 3.2 and 85,000 feet, 25,900 meters, allowing it to outrace or entirely avoid threats. If a surface-to-air missile launch was detected, the standard evasive action was simply to accelerate and outpace the missile. On average, each State Route 71 could fly once per week due to the extended turnaround required after mission recovery. A total of 32 aircraft were built, 12 were lost in accidents with none lost to enemy action. In 1989, the USAF retired the State Route 71 largely for political reasons. Several were briefly reactivated during the 1990s before their second retirement in 1998. NASA was the final operator of the Blackbird, who used it as a research platform, retiring it in 1999. Since its retirement, the SR-71's role has been taken up by a combination of reconnaissance satellites and unmanned aerial vehicles, UAVs. A proposed UAV successor, the State Route 72, is under development by Lockheed Martin and scheduled to fly in 2025. The State Route 71 has several nicknames, including Blackbird and Habu. As of 2023, the State Route 71 holds the world record it set in 1976 as the fastest air-breathing manned aircraft, previously held by the related Lockheed YF-12. Development. Lockheed's previous reconnaissance aircraft was the relatively slow U-2, designed for the Central Intelligence Agency, CIA. In late 1957, the CIA approached the defense contractor Lockheed to build an undetectable spy plane. The project, named Archangel, was led by Kelly Johnson, head of Lockheed's Skunk Works unit in Burbank, California. The work on Project Archangel began in the second quarter of 1958, with aim of flying higher and faster than the U-2. Of 11 successive designs drafted in a span of 10 months, I-10 was the frontrunner. Despite this, however, its shape made it vulnerable to radar detection. After a meeting with the CIA in March 1959, the design was modified to have a 90% reduction in radar cross-section. The CIA approved a $96 million contract for Skunk Works to build a dozen spy planes, named A-12, on February 11, 1960. The 1960 downing of Francis Gary Powers' U-2 underscored the aircraft's vulnerability and the need for faster reconnaissance aircraft such as the A-12. The A-12 first flew at Groom Lake, Area 51, Nevada, on April 25, 1962. 13 were built. 2 variants were also developed, including 3 of the YF-12 Interceptor prototype and 2 of the M21 drone carrier. The aircraft was meant to be powered by the Pratt & Whitney J58 engine, but development ran over schedule, and it was equipped instead with the less powerful Pratt & Whitney J75 initially. The J58s were retrofitted as they became available, and became the standard engine for all subsequent aircraft in the series, A-12, YF-12, M-21, as well as the State Route 71. The A-12 flew missions over Vietnam and North Korea before its retirement in 1968. The program's cancellation was announced on December 28, 1966, due both to budget concerns and because of the forthcoming State Route 71, a derivative of the A-12. Designation is State Route 71. The State Route 71 designation is a continuation of the pre-1962 bomber series. The last aircraft built using the series was the XB-70 Valkyrie. However, a bomber variant of the Blackbird was briefly given the B-71 designator, which was retained when the type was changed to State Route 71. During the later stages of its testing, the B-70 was proposed for a reconnaissance/strike role with an RS-70 designation. When the A-12's performance potential was clearly found to be much greater, the USAF ordered a variant of the A-12 in December 1962, which was originally named R-12 by Lockheed. This USAF version was longer and heavier than the original A-12 because it had a longer fuselage to hold more fuel. The R-12 also had a larger two-seat cockpit and reshaped fuselage chins. Reconnaissance equipment included signals intelligence sensors, a side-looking airborne radar, and a photo camera. The CIA's A-12 was a better photo reconnaissance platform than the USAF's R-12, since the A-12 flew somewhat higher and faster, and with only one pilot, it had room to carry a superior camera and more instruments. The A-12 flew covert missions while the State Route 71 flew overt missions. The latter had USAF markings and pilots carried Geneva Convention's identification cards. During the 1964 campaign, Republican presidential nominee Barry Goldwater repeatedly criticized President Lyndon B. Johnson and his administration for falling behind the Soviet Union in developing new weapons. Johnson decided to counter this criticism by revealing the existence of the YF-12, a USAF interceptor, which also served as cover for the still-secret A-12 and the USAF reconnaissance model since July 1964. USAF Chief of Staff General Curtis LeMay preferred the SR, Strategic Reconnaissance, designation and wanted the RS-71 to be named State Route 71. Before the July speech, LeMay lobbied to modify Johnson's speech to read State Route 71 instead of RS-71. The media transcript given to the press at the time still had the earlier RS-71 designation in places, creating the story that the president had misread the aircraft's designation. To conceal the A-12's existence, Johnson referred only to the A-11, while revealing the existence of a high-speed, high-altitude reconnaissance aircraft. In 1968, Secretary of Defense Robert McNamara canceled the F-12 interceptor program. The specialized tooling used to manufacture both the YF-12 and the State Route 71 was also ordered destroyed. Production of the State Route 71 totaled 32 aircraft with 29 SR-71s, 2 SR-71Bs, and the single SR-71C. Design. The State Route 71 was designed for flight at over Mach 3 with a flight crew of 2 in tandem cockpits, with the pilot in the forward cockpit and the reconnaissance systems officer operating the surveillance systems and equipment from the rear cockpit and directing navigation on the mission flight path. The State Route 71 was designed to minimize its radar cross-section, an early attempt at stealth design. Finished aircraft were painted a dark blue, almost black, to increase the emission of internal heat and to act as camouflage against the night sky. The dark color led to the aircraft's nickname Blackbird. While the State Route 71 carried radar countermeasures to evade interception efforts, its greatest protection was its combination of high altitude and very high speed, which made it almost invulnerable. Along with its low radar cross-section, these qualities gave a very short time for an enemy surface-to-air missile, SAM, sight to acquire and track the aircraft on radar. By the time the SAM sight could track the State Route 71, it was often too late to launch a SAM, and the State Route 71 would be out of range before the SAM could catch up to it. If the SAM sight could track the State Route 71 and fire a SAM in time, the SAM would expend nearly all of the delta V of its boost and sustainer phases just reaching the SR-71's altitude. At this point, out of thrust, it could do little more than follow its ballistic arc. Merely accelerating would typically be enough for an State Route 71 to evade a SAM. Changes by the pilots in the SR-71's speed, altitude, and heading were also often enough to spoil any radar lock on the plane by SAM sites or enemy fighters. At sustained speeds of more than Mach 3.2, the plane was faster than the Soviet Union's fastest interceptor, the Mikoyan-Gurevich MiG-25, which also could not reach the SR-71's altitude. During its service life, no State Route 71 was ever shot down. Airframe, canopy, and landing gear. On most aircraft, the use of titanium was limited by the costs involved. It was generally used only in components exposed to the highest temperatures, such as exhaust fairings and the leading edges of wings. On the State Route 71, titanium was used for 85% of the structure, with much of the rest polymer composite materials. To control costs, Lockheed used a more easily worked titanium alloy which softened at a lower temperature. The challenges posed led Lockheed to develop new fabrication methods, which have since been used in the manufacture of other aircraft. Lockheed found that washing welded titanium requires distilled water, as the chlorine present in tap water is corrosive. Cadmium-plated tools could not be used, as they also caused corrosion. Metallurgical contamination was another problem. At one point, 80% of the delivered titanium for manufacture was rejected on these grounds. The high temperatures generated in flight required special design and operating techniques. Major sections of the skin of the inboard wings were corrugated, not smooth. Aerodynamicists initially opposed the concept, disparagingly referring to the aircraft as a Mach 3 variant of the 1920s-era Ford Trimitar, which was known for its corrugated aluminum skin. The heat would have caused a smooth skin to split or curl, whereas the corrugated skin could expand vertically and horizontally and had increased longitudinal strength. Fuselage panels were manufactured to fit only loosely with the aircraft on the ground. Proper alignment was achieved as the airframe heated up, with thermal expansion of several inches. Because of this, and the lack of a fuel sealing system that could handle the airframe's expansion at extreme temperatures, the aircraft leaked JP-7 fuel on the ground prior to takeoff, annoying ground crews. The outer windscreen of the cockpit was made of quartz and was fused ultrasonically to the titanium frame. The temperature of the exterior of the windscreen reached 600 degrees Fahrenheit 316 degrees Celsius during a mission. Cooling was carried out by cycling fuel behind the titanium surfaces in the chins. On landing, the canopy temperature was over 572 degrees Fahrenheit 300 degrees Celsius. Some SR-71s featured red stripes to prevent maintenance workers from damaging the thin, fragile skin located near the center of the fuselage. This portion of the skin was only supported by widely spaced structural ribs. The Blackbird's tires, manufactured by B.F. Goodrich, contained aluminum and were filled with nitrogen. They cost $2,300 and would generally require replacing within 20 missions. The Blackbird landed at over 170 knots, 200 miles per hour, 310 kilometers per hour, and deployed a drag parachute to stop. The chute also acted to reduce stress on the tires. Shape and threat avoidance. The second operational aircraft designed around a stealth aircraft shape and materials. After the Lockheed A-12, the State Route 71 had several features designed to reduce its radar signature. The State Route 71 had a radar cross-section, RCS, around 110 square feet, 10 square meters. Drawing on early studies in radar stealth technology, which indicated that a shape with flattened, tapering sides would reflect most energy away from a radar beam's place of origin, engineers added chins and canted the vertical control surfaces inward. Special radar-absorbing materials were incorporated into sawtooth-shaped sections of the aircraft's skin. Cesium-based fuel additives were used to somewhat reduce exhaust plumes' visibility to radar, although exhaust streams remained quite apparent. Kelly Johnson later conceded that Soviet radar technology advanced faster than the stealth technology employed against it. The State Route 71 featured chins, a pair of sharp edges leading aft from either side of the nose along the fuselage. These were not a feature on the early A-3 design. Frank Rogers, a doctor at the Scientific Engineering Institute, a CIA front organization, discovered that a cross-section of a sphere had a greatly reduced radar reflection, and adapted a cylindrical-shaped fuselage by stretching out the sides of the fuselage. After the advisory panel provisionally selected Convair's fish design over the A-3 on the basis of RCS, Lockheed adopted chins for its A4 through A6 designs. Aerodynamicists discovered that the chins generated powerful vortices and created additional lift, leading to unexpected aerodynamic performance improvements. The angle of incidence of the delta wings could be reduced for greater stability and less drag at high speeds, and more weight carried, such as fuel. Landing speeds were also reduced, as the chin's vortices created turbulent flow over the wings at high angles of attack, making it harder to stall. The chins also acted like leading-edge extensions, which increased the agility of fighters such as the F-5, F-16, F/A-18, MiG-29, and Su-27. The addition of chins also allowed the removal of the planned Canard 4 planes. Air inlets. The air inlets allowed the State Route 71 to cruise at over Mach 3.2, with the air slowing down to subsonic speed as it entered the engine. Mach 3.2 was the design point for the aircraft, its most efficient speed. However, in practice the State Route 71 was sometimes more efficient at even faster speeds, depending on the outside air temperature, as measured by pounds of fuel burned per nautical mile traveled. During one mission, State Route 71 pilot Brian Schul flew faster than usual to avoid multiple interception attempts. Afterward, it was discovered that this had reduced fuel consumption. At the front of each inlet, a pointed, movable inlet cone called a spike was locked in its full forward position on the ground and during subsonic flight. When the aircraft accelerated past Mach 1.6, an internal jack screw moved the spike up to 26 in, 66 centimeters, inwards, directed by an analog air inlet computer that took into account pitot-static system, pitch, roll, yaw, and angle of attack. Moving the spike tip drew the shock wave riding on it closer to the inlet cowling until it touched just slightly inside the cowling lip. This position reflected the spike shock wave repeatedly between the spike center body and the inlet intercowl sides, and minimized airflow spillage, which is the cause of spillage drag. The air slowed supersonically with a final plane shock wave at entry to the subsonic diffuser. Downstream of this normal shock, the air is subsonic. It decelerates further in the divergent duct to give the required speed at entry to the compressor. Capture of the plane shock wave within the inlet is called starting the inlet. Bleed tubes and bypass doors were designed into the inlet and engine nacelles to handle some of this pressure and to position the final shock to allow the inlet to remain started. In the early years of operation, the analog computers would not always keep up with rapidly changing flight environmental inputs. If internal pressures became too great and the spike was incorrectly positioned, the shock wave would suddenly blow out the front of the inlet, called an inlet unstart. During unstarts, afterburner extinctions were common. The remaining engine's asymmetrical thrust would cause the aircraft to yaw violently to one side. SAS, autopilot, and manual control inputs would fight the yawing, but often the extreme off angle would reduce airflow in the opposite engine and stimulate sympathetic stalls. This generated a rapid counter-yawing, often coupled with loud banging noises, and a rough ride during which crew's helmets would sometimes strike their cockpit canopies. One response to a single unstart was unstarting both inlets to prevent yawing, then restarting them both. After wind tunnel testing and computer modeling by NASA Dryden Test Center, Lockheed installed an electronic control to detect unstart conditions and perform this reset action without pilot intervention. During troubleshooting of the unstart issue, NASA also discovered the vortices from the nose chins were entering the engine and interfering with engine efficiency. NASA developed a computer to control the engine bypass doors, which countered this issue and improved efficiency. Beginning in 1980, the analog inlet control system was replaced by a digital system, which reduced unstart instances. Engines. The State Route 71 was powered by two Pratt & Whitney J58, company designation JT11D20, axial flow turbojet engines. The J58 was a considerable innovation of the era, capable of producing a static thrust of 32,500 lbf, 145 knots. The engine was most efficient around Mach 3.2, the Blackbird's typical cruising speed. At takeoff, the afterburner provided 26% of the thrust. This proportion increased progressively with speed until the afterburner provided all the thrust at about Mach 3. Air was initially compressed and heated by the inlet spike and subsequent converging duct between the center body and inlet cowl. The shock waves generated slowed the air to subsonic speeds relative to the engine. The air then entered the engine compressor. Some of this compressor flow, 20% at cruise, was removed after the fourth compressor stage and went straight to the afterburner through 6 bypass tubes. Air passing through the turbojet was compressed further by the remaining 5 compressor stages, and then fuel was added in the combustion chamber. After passing through the turbine, the exhaust, together with the compressor bleed air, entered the afterburner. At around Mach 3, the temperature rise from the intake compression, added to the engine compressor temperature rise, reduced the allowable fuel flow because the turbine temperature limit did not change. The rotating machinery produced less power, but still enough to run at 100% RPM, thus keeping the airflow through the intake constant. The rotating machinery had become a drag item, and the engine thrust at high speeds came from the afterburner temperature rise. Maximum flight speed was limited by the temperature of the air entering the engine compressor, which was not certified for temperatures above 800 degrees Fahrenheit 430 degrees Celsius. Originally, the Blackbird's J58 engines were started with the assistance of 2 Buick Wildcat V8 internal combustion engines, externally mounted on a vehicle referred to as an AG330 start cart. The start cart was positioned underneath the J58, and the 2 Buick engines powered a single, vertical drive shaft connecting to the J58 engine and spinning it to above 3,200 RPM, at which point the turbojet could self-sustain. Once the first J58 engine was started, the cart was repositioned to start the aircraft's other J58 engine. Later start carts used Chevrolet big block V8 engines. Eventually, a quieter, pneumatic start system was developed for use at main operating bases. The V8 start carts remained at diversion landing sites not equipped with the pneumatic system. Fuel. Several exotic fuels were investigated for the Blackbird. Development began on a coal slurry power plant, but Johnson determined that the coal particles damaged important engine components. Research was conducted on a liquid hydrogen power plant, but the tanks for storing cryogenic hydrogen were not of a suitable size or shape. In practice, the Blackbird would burn somewhat conventional JP7, which was difficult to ignite. To start the engines, triethylborane, TEB, which ignites on contact with air, was injected to produce temperatures high enough to ignite the JP7. The TEB produced a characteristic green flame, which could often be seen during engine ignition. On a typical mission, the State Route 71 took off with only a partial fuel load to reduce stress on the brakes and tires during takeoff and also ensure it could successfully take off should one engine fail. Within 20 seconds, the aircraft traveled 4,500 feet, 1,400 meters, reached 240 miles per hour, 390 kilometers per hour, and lifted off. It reached 20,000 feet, 6,100 meters, of altitude in less than 2 minutes, and the typical 80,000 feet, 24,000 meters, cruising altitude in another 17 minutes, having used 1/3 of its fuel. It is a common misconception that the planes refueled shortly after takeoff because the jet fuel leaked. The leaking of fuel was an intentional design feature because the high heat generated by the aircraft made it impossible to fully seal the fuselage tanks against leaks. However, the amount of fuel that leaked was not enough to make the refueling necessary. The planes refueled because the maximum speeds of the aircraft were only possible with aerial refueling. The State Route 71 also required in-flight refueling to replenish fuel during long-duration missions. Supersonic flights generally lasted no more than 90 minutes before the pilot had to find a tanker. Specialized KC-135Q tankers were required to refuel the State Route 71. The KC-135Q had a modified high-speed boom, which would allow refueling of the Blackbird at nearly the tanker's maximum airspeed with minimum flutter. The tanker also had special fuel systems for moving JP4, for the KC-135Q itself, and JP7, for the State Route 71, between different tanks. As an aid to the pilot when refueling, the cockpit was fitted with a peripheral vision horizon display. This unusual instrument projected a barely visible artificial horizon line across the top of the entire instrument panel, which gave the pilot subliminal cues on aircraft attitude. Astro-Inertial Navigation System. Nortronics, Northrop Corporation's Electronics Development Division, had developed an Astro-Inertial Guidance System, ANS, which could correct inertial navigation system errors with celestial observations, for the SM-62 Snark missile, and a separate system for the ill-fated AGM-48 Skybolt missile, the latter of which was adapted for the State Route 71. Before takeoff, a primary alignment brought the ANS's inertial components to a high degree of accuracy. In flight, the ANS, which sat behind the reconnaissance systems officers, RSO's, position, tracked stars through a circular quartz glass window on the upper fuselage. Its blue light source star tracker, which could see stars during both day and night, would continuously track a variety of stars as the aircraft's changing position brought them into view. The system's digital computer ephemeris contained data on a list of stars used for celestial navigation. The list first included 56 stars and was later expanded to 61. The ANS could supply altitude and position to flight controls and other systems, including the mission data recorder, automatic navigation to preset destination points, automatic pointing and control of cameras and sensors, and optical or SLR sighting of fixed points loaded into the ANS before takeoff. According to Richard Graham, a former State Route 71 pilot, the navigation system was good enough to limit drift to 1,000 feet, 300 meters, off the direction of travel at Mach 3. Sensors and payloads. The State Route 71 originally included optical/infrared imagery systems, side-looking airborne radar, SLAR, electronic intelligence, ELINT, gathering systems, defensive systems for countering missile and airborne fighters, and recorders for SLAR, ELINT, and maintenance data. The State Route 71 carried a Fairchild tracking camera and an infrared camera, both of which ran during the entire mission. As the State Route 71 had a second cockpit behind the pilot for the RSO, it could not carry the A-12's principal sensor, a single large focal length optical camera that sat in the Q bay behind the A-12's single cockpit. Instead, the SR-71's camera systems could be located either in the fuselage chins or the removable nose/chine section. Wide-area imaging was provided by two of ITEC's operational objective cameras, which provided stereo imagery across the width of the flight track, or an ITEC optical bar camera, which gave continuous horizon-to-horizon coverage. A closer view of the target area was given by the HICON Technical Objective Camera, TOC, which could be directed up to 45 degrees left or right of the centerline. Initially, the TOCs could not match the resolution of the A-12's larger camera, but rapid improvements in both the camera and film improved this performance. SLAR, built by Goodyear Aerospace, could be carried in the removable nose. In later life, the radar was replaced by Loral's Advanced Synthetic Aperture Radar System, ASARS-1. Both the first SLAR and ASARS-1 were ground mapping imaging systems, collecting data either in fixed swaths left or right of centerline or from a spot location for higher resolution. ELINT gathering systems, called the Electromagnetic Reconnaissance System, built by AIL, could be carried in the chine bays to analyze electronic signal fields being passed through, and were programmed to identify items of interest. Over its operational life, the Blackbird carried various electronic countermeasures, ECMs, including warning and active electronic systems built by several ECM companies and called Systems A, A2, A2C, B, C, C2, E, G, H, and M. On a given mission, an aircraft carried several of these frequencies/purpose payloads to meet the expected threats. Major Jerry Crew, an RSO, told Air and Space/Smithsonian that he used a jammer to try to confuse surface-to-air missile sites as their crews tracked his airplane, but once his threat warning receiver told him a missile had been launched, he switched off the jammer to prevent the missile from homing in on its signal. After landing, information from the SLAR, ELINT gathering systems, and the maintenance data recorder were subjected to post-flight ground analysis. In the later years of its operational life, a data link system could send ASARS-1 and ELINT data from about 2,000 nmi, 3,700 kilometers, of track coverage to a suitably equipped ground station. Initial retirement. One widely conventional view, and probably the best-known view, of the reasons for the SR-71's retirement in 1989, a view that the Air Force itself offered to the Congress, was that besides being very expensive, the State Route 71 had become redundant anyway, among other reconnaissance methods that were ever evolving. However, another view held by various officers and legislators is that the State Route 71 program was terminated owing to Pentagon politics, and not because the aircraft had become obsolete, irrelevant, too hard to maintain, or unsustainably expensive. Graham, a former 1st SRS and 9th SRW commander, presented in 1996 what he viewed as a factual summary, not an opinion, of how the State Route 71 provided some intelligence capabilities that none of its alternatives, such as satellites, U-2s, and UAVs, were providing in the 1990s, when the State Route 71 was retired and then re-retired from Air Force reconnaissance duty. The chief question for opinion, beyond that point, was only how crucial, or disposable, those unique advantages properly were. Graham noted that in the 1970s and early 1980s, State Route 71 squadron and wing commanders were often promoted into higher positions as general officers within the USAF structure and the Pentagon. In order to be selected into the State Route 71 program in the first place, a pilot or navigator, RSO, had to be a top-quality USAF officer, so continuing career progression for members of this elite group was not surprising. These generals were adept at communicating the value of the State Route 71 to a USAF command staff and a Congress who often lacked a basic understanding of how the State Route 71 worked and what it did. However, by the mid-1980s, these State Route 71 generals all had retired, and a new generation of USAF generals mostly wanted to cut the program's budget and spend its funding on different priorities, such as the very expensive new B-2 Spirit strategic bomber program. Such generals had an interest in believing, and persuading the services and the Congress, that the State Route 71 had become either entirely or almost entirely redundant to satellites, U-2s, incipient UAV programs, and an alleged top-secret successor already under development. Graham said that the last mentioned one was only a sales pitch, not a fact, at the time in the 1990s. The USAF may have seen the State Route 71 as a bargaining chip to ensure the survival of other priorities. Also, the State Route 71 program's product, which was operational and strategic intelligence, was not seen by these generals as being very valuable to the USAF. The primary consumers of this intelligence were the CIA, NSA, and DIA. A general misunderstanding of the nature of aerial reconnaissance and a lack of knowledge about the State Route 71 in particular, due to its secretive development and operations, was used by detractors to discredit the aircraft, with the assurance given that a replacement was under development. Dick Cheney told the Senate Appropriations Committee that the State Route 71 cost $85,000 per hour to operate. Opponents estimated the aircraft's support cost at $400 to $700 million per year, though the cost was actually closer to $300 million. The State Route 71, while much more capable than the Lockheed U-2 in terms of range, speed, and survivability, suffered the lack of a data link, which the U-2 had been upgraded to carry. This meant that much of the SR-71's imagery and radar data could not be used in real time, but had to wait until the aircraft returned to base. This lack of immediate real-time capability was used as one of the justifications to close down the program. The counterargument was that the longer the State Route 71 was not upgraded as aggressively as it ought to have been, the more people could say that it was obsolescent, which was in their interest as champions of other programs, a self-fulfilling bias. Attempts to add a data link to the State Route 71 were stymied early on by the same factions in the Pentagon and Congress who were already set on the program's demise, even in the early 1980s. These same factions also forced expensive sensor upgrades to the State Route 71, which did little to increase its mission capabilities, but could be used as justification for complaining about the cost of the program. In 1988, Congress was convinced to allocate $160,000 to keep 6 SR-71s and a trainer model in flyable storage that could become flight-worthy within 60 days. However, the USAF refused to spend the money. While the State Route 71 survived attempts to retire it in 1988, partly due to the unmatched ability to provide high-quality coverage of the Kola Peninsula for the U.S. Navy, the decision to retire the State Route 71 from active duty came in 1989, with the last missions flown in October that year. 4 months after the plane's retirement, General Norman Schwarzkopf Jr. was told that the expedited reconnaissance, which the State Route 71 could have provided, was unavailable during Operation Desert Storm. The State Route 71 program's main operational capabilities came to a close at the end of fiscal year 1989, October 1989. The 1st Strategic Reconnaissance Squadron, 1 SRS, kept its pilots and aircraft operational and active, and flew some operational reconnaissance missions through the end of 1989 and into 1990, due to uncertainty over the timing of the final termination of funding for the program. The squadron finally closed in mid-1990, and the aircraft were distributed to static display locations, with a number kept in reserve storage. Deactivation. From the operator's perspective, what I need is something that will not give me just a spot in time but will give me a track of what is happening. When we are trying to find out if the Serbs are taking arms, moving tanks or artillery into Bosnia, we can get a picture of them stacked up on the Serbian side of the bridge. We do not know whether they then went on to move across that bridge. We need the data that a tactical, in State Route 71, a U-2, or an unmanned vehicle of some sort, will give us, in addition to, not in replacement of, the ability of the satellites to go around and check not only that spot but a lot of other spots around the world for us. It is the integration of strategic and tactical. Response from Admiral Richard C. Mack to the Senate Committee on Armed Services. Due to unease over political situations in the Middle East and North Korea, the U.S. Congress re-examined the State Route 71 beginning in 1993. Rear Admiral Thomas F. Hall addressed the question of why the State Route 71 was retired, saying it was under the belief that, given the time delay associated with mounting a mission, conducting a reconnaissance, retrieving the data, processing it, and getting it out to a field commander, that you had a problem in timelines that was not going to meet the tactical requirements on the modern battlefield. And the determination was that if one could take advantage of technology and develop a system that could get that data back real time, that would be able to meet the unique requirements of the tactical commander. Hall also stated they were looking at alternative means of doing the job of the State Route 71. Mack told the committee that they were flying U-2s, RC-135s, and other strategic and tactical assets to collect information in some areas. Senator Robert Byrd and other senators complained that the better-than-successor to the State Route 71 had yet to be developed at the cost of the good-enough serviceable aircraft. They maintained that, in a time of constrained military budgets, designing, building, and testing an aircraft with the same capabilities as the State Route 71 would be impossible. Congress's disappointment with the lack of a suitable replacement for the Blackbird was cited concerning whether to continue funding imaging sensors on the U-2. Congressional conferees stated that experience with the State Route 71 serves as a reminder of the pitfalls of failing to keep existing systems up to date and capable in the hope of acquiring other capabilities. It was agreed to add $100 million to the budget to return 3 SR-71s to service, but it was emphasized that this would not prejudice support for long-endurance UAVs, such as the Global Hawk. The funding was later cut to $72.5 million. The Skunk Works was able to return the aircraft to service under budget at $72 million. Retired USAF Colonel Jay Murphy was made the program manager for Lockheed's reactivation plans. Retired USAF Colonels Don Emmons and Barry McKean were put under government contract to remake the plane's logistic and support structure. Still active USAF pilots and reconnaissance systems officers, RSOs, who had worked with the aircraft were asked to volunteer to fly the reactivated planes. The aircraft was under the command and control of the 9th Reconnaissance Wing at Beale Air Force Base and flew out of a renovated hangar at Edwards Air Force Base. Modifications were made to provide a data link with near real-time transmission of the advanced synthetic aperture radar's imagery to sites on the ground. Final retirement. The reactivation met much resistance. The USAF had not budgeted for the aircraft, and UAV developers worried that their programs would suffer if money was shifted to support the SR-71s. Also, with the allocation requiring yearly reaffirmation by Congress, long-term planning for the State Route 71 was difficult. In 1996, the USAF claimed that specific funding had not been authorized, and moved to ground the program. Congress reauthorized the funds, but, in October 1997, President Bill Clinton attempted to use the line-item veto to cancel the $39 million allocated for the State Route 71. In June 1998, the U.S. Supreme Court ruled that the line-item veto was unconstitutional. All this left the SR-71's status uncertain until September 1998, when the USAF called for the funds to be redistributed. The USAF permanently retired it in 1998. NASA operated the 2 last airworthy Blackbirds until 1999. All other Blackbirds have been moved to museums except for the two SR-71s and a few D-21 drones retained by the NASA Dryden Flight Research Center, later renamed the Armstrong Flight Research Center.